Hi, and welcome back, everyone. We're going to look at transformations of functions today. So if you think about, what does the word transformation mean? It means to change things, right? Like the transformers. So we're going to take our 8 common functions, and it's very important to know how to sketch each one because we're going to be sketching graphs that are almost like the graphs of the common functions that we know. And the reason they're almost like it is because they're going to transform in some way. So they're either going to move up or down, left or right on the coordinate plane. They may flip over, which will be a reflection. They could shrink. They could stretch. So we're going to look at what parts of the equation cause those things to happen, cause those transformations. So the first transformation we're going to look at is what's called vertical shifting. So remember, vertical means up or down, right? Like think of vertical blinds. So it means go up or go down. And the way we're going to determine whether something graphs up or down is by taking the function and either adding or subtracting this k value to it. K is going to control the vertical shift. So I'm going to go to Desmos and I'm going to add in this equation here. So y equals, we're going to look at the x squared, which is our parabola. We're going to put plus k. And k is going to be a slider. So you're going to click add slider. If you just click on the k, it will create a slider for you. So now you can literally slide that circle right and left and watch what happens to k. So when k gets bigger, greater than 0, what do you notice is happening to the parabola? When k is getting less than 0, what do you notice is happening to the parabola? So hopefully you see that when k is getting bigger than 0, positive, it's shifting up. So that's a vertical shift up. And when k is getting less than 0, you're vertically shifting down. The mathematical word, by the way, for shifting is translating. So translating is like sliding. So let's write that down. If k is greater than 0, the graph is, which just means, remember, that's just saying positive. And when it's less than, that's saying negative. So when k is positive, the graph is going to shift up k units. And if it's negative, it's going to shift down k units. So here, if I was to plug in my values and look at the original function, the common function, if I plug in -2 and square it, I get 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Now, if I take that function and I add 3, that should give me a vertical shift up 3, right? So my y values are going to increase by 3. 4 plus 3 is 7. 1 plus 3, 4. 0 plus 3, 3. 1 plus 3, 4. And 4 plus 3, 7. So now you can see you've got your new points. Here's -2, 7. Here's -1, 4. Here's 0, 3. Here's 1, 4. And here's 2, 7. Okay, and as you can see, it's the same parabola. It's just shifted up 3 units. Okay, so that's a vertical shift up 3 units. If it was a -3, it would take the parabola or whatever common function it is and shift it down. So how do we know whether a graph shifts right or left? Now we're looking at this h value inside. And even though it says x minus h, you're going to do the opposite of what you see inside the parentheses, or it might not even be parentheses. It could be under a square root symbol or inside an absolute value bars, but it groups it somehow, okay? So you're going to do the opposite. That's what a minus means. So here, if we take the same function, y equals x squared, but this time we're going to do x minus h squared, and h will be a slider, okay? So I've still got y equals x squared, but this time, like I said, we're going to have y equals, and then in parentheses, x minus h, okay, close your parentheses, squared. And again, I'm going to click on add slider. It's going to create a slider. So now when h gets greater than 0, you should notice that the graph is moving to the right. And when h is less than 0, it's moving to the left. Okay. So when h is greater than 0, it's going to move to the right. And when h is less than 0, it's going to move to the left. Okay. So if we take the square root function now, and I do the square root of 0, it's 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Okay, that's our common function. As you can see, it's the black function there. That's the square root function. All right. Now I'm going to take my y values, and remember y is just g of x. I'm going to take the square root of x and just set it equal to all these values. So I'm going to have like 0 equals the square root of x minus 2. 1 equals the square root of x minus 2. 2 equals the square root of x minus 2. 3 equals the square root of x minus 2. And we're just going to work backwards and solve for x. Like, what would the x value be? Okay, so I'll take this last one here. 3 equals the square root of x minus 2. If I want to solve that equation, I have to undo the square root. So to do that, I'm going to square both sides. Squaring both sides will eliminate the radical, the square root, and you'll be left with what's underneath, so the radicand. 3 squared gives me 9, and you get x minus 2. Now to solve for x, you're just going to add 2 to both sides, so you get x equals 11, right? So this will be 11, and you could do that for each of these, and you'll get the following values. So there's my new ordered pairs, which you can see. Here's 2, 0. Here's 6, 2. 11, 3 would be on there. 3, 1 is also on there, right? Here's 3, 1. It's just not labeled. 11, 2 is right, or 11, 3 rather is right there. So as you can see here, when it was the square root of x minus 2, it actually made the graph go 2 units to the right. So you might look at that and go, well, wait a minute. I thought h was less than 0. It's not. So here you want to think of this as x minus a positive 2. So h here is positive 2. It's greater than 0, so it's going to shift to the right. The way I look at it is, whenever it's inside, like a square root, or if you have something in parentheses, like x minus 2 squared, it's the opposite of what you see there, right? So think of the parentheses or the square root as like, you know, a jail, and you're in jail because you did the opposite of what you should have done, okay? So it's not really a negative 2, it's really a positive 2. So h is greater than 0 in this case, and it's going to move to the right, okay? So if I was to look at this one here, which I'll save for you all to do on your own, this x plus 3 there, that's going to make the graph go left 3. So that's a horizontal shift to the left. Because if I was to rewrite it, remember, it's x minus h. So it's really x minus negative 3. And we know two negatives give you a positive. Okay, so please remember for horizontal, it's really the opposite of what you see. So if you see a plus in there, you're really going to the left. And if you see a minus, you're really going to the right. Okay, reflection. So you can reflect over the x-axis, you can reflect over the y-axis. How do we tell the difference? So when you're multiplying the whole expression by a negative, so f of x is the entire expression. When there's a negative on the outside, it's reflecting over the x-axis. This time, though, if you look, the negatives on the inside with the x, that's going to reflect the function across the y-axis instead. Okay, so let's take a look at an example. So this time I'm going to use the square root of x for my function. Okay, so here's y equals the square root of x, okay, which we know looks like that. So now watch when I do y equals negative. So I'm going to put a negative on the outside. I'm multiplying the whole function by a negative. As you can see with that red piece of the graph, it's the square root function, but it's reflected or flipped over the x-axis, right? So anytime you're multiplying the outside by a negative, it's going to flip the function over the x-axis. It reflects it over x. Now, if I was to take the negative and put it on the inside, now you can see that the graph flips or reflects over the y-axis because now you're multiplying the x's by a negative. And then what happens when I put a negative on the outside and keep the negative on the inside? What do you think will happen? So now, as you can see, it reflected it over the x and the y, and it really reflected it over the origin, right? So it's reflected over the origin there. It kind of did a double reflection. It first reflected over the x and then over the y. So you can play around with that to see there. So the square root of x we know lies in quadrant 1. So remember your quadrants look like this. So here's quadrant 1. If I'm looking at the coordinate plane, it goes counterclockwise. So the square root of x is in quadrant 1. Okay? When I reflected the graph, when I changed that function to y equals negative square root of x, remember it reflected over the x-axis. So it was in quadrant 1, now it's going to end up in quadrant 4. Oh, sorry, they wanted x-axis here. And then the answer to this is quadrant 4. Jumping ahead. When I have the negative on the inside, remember that's reflecting over the y-axis. And if I was in quadrant 1 originally for my first function, now it's going to reflect it into quadrant 2. And then remember when I put a negative on the outside and the inside, it really reflected it over the x and the y-axis, okay, or the origin, and it ended up in quadrant 3. Okay, let's look at shrinks, also known as compressions, like to compress something. Think of compression pants, right? And stretches, to pull on something. Okay, first we're going to take care of vertical shrinks and stretches. So if we're given a function, right, it's going to be a vertical stretch. We're going to pay attention to this value out here, this a. If the absolute value of a is greater than 1, so it doesn't matter if it's negative, remember all a negative will do will reflect it. If that value, the absolute value of it is greater than 1, it's going to stretch the graph. If the absolute value of a is less than 1, it's going to shrink the graph, okay? And I gave you a tip here. In order to figure out the new ordered pairs, you'd want to multiply all the y values by the absolute value of a, okay? And we'll see examples of that. So let's take a look at this for a second, okay? So I'm going to type into my Desmos here. Again, you've got y equals, and this time I'm going to type in a times the absolute value, or times x squared. Okay, so let's look at the parabola again. And a is going to be a slider. Okay, so now watch what happens when a is greater than 0, when it gets bigger. Okay, as you can see here, it's vertically stretching the graph. It's pulling on it, making it more narrow. Like think of a rubber band. If you pull on it vertically up and down, it gets narrower. What happens when you push down on it? It's going to get wider. Okay, so as a gets less than 1, it's going to get wider. Okay, so here, If a is greater than 1, the graph gets narrower. And this is called a vertical stretch. If a is between 0 and 1, what happened? It got wider, as we saw. Okay, and this is called a vertical shrink, or sometimes I may refer to it as a compression. So if we look at this example here, we're going to take the x cubed function, and if I pay attention to the a value, right, I want to look at the absolute value of a, because I don't care if it was a negative 1/8, a negative will just reflect it. The absolute value of 1/8 is just 1/8, okay? 1/8 is between 0 and 1. That tells me that this is going to be a vertical compression. It's going to take the graph and it's going to get wider, okay? So you'll see. So first, if I was to graph the common function, I'm just going to plug in -4 and cube it, -3 cubed, -2 cubed, -1 cubed, and so on. Okay, and I'm only going to be able to graph a few of those. So I'm only going to graph from here to here. That's all I can fit on the graph. So -2, -8, -1, -1, 0, 0, 1, 1, and then 2, 8. Okay, remember that it kind of looks like this. Okay, that's what the cubic function looks like. So now what's going to happen with that 1/8, it's going to vertically shrink it, which means it's going to get wider. So I gave you a tip above where I said multiply all the y values by the absolute value of a. So here a is 1/8. So I'm going to take all of these y values and just multiply them by 1/8, or you could divide all of them by 8, right? It's the same thing. And that's going to give me my new values. So -64 divided by 8 is -8. -3 or -27 divided by 8, it's going to just give me -27/8, which is not a nice number to graph, so we won't bother graphing that one. -2/8 is 1/4. That's wrong. That should be -8/8, so that's -1. And then -1/8, we're going to not graph that one. 0/8, 1/8, 8/8, 27/8, and 64/8. Okay, so I'm only going to pick and choose. Like, this is a good one to graph. These are all good ones, the ones I'm putting dots next to. So -4, -8, and let me pick a different color to do this in. 1, 2, 3, 4, and then down 8. 1, 2, 3, 5, 6, 7, 8. So my new point's right there, okay? And -2, -1 is right, whoops, is right here. 0, 0 stayed where it is. 2, 1 is here, and 4/8. So you can kind of see here how the graph is kind of being vertically compressed, right? It's getting wider as you can see it. Like especially this part in here, if you compare it to the original piece, which is right in here, it got wider. So it's like someone's pushing on it vertically, so it's going to get fatter. Okay, and then the last type of transformation we're going to look at are what's called horizontal compressions, also known as shrinks, right, or stretches. So this time, again, as with when we did horizontal shifting, it is involving the x value on the inside. So notice that here you've got parentheses and then b times x. So it's going to be a horizontal shrink if the absolute value of b is greater than 1, and it's going to be a horizontal stretch if the absolute value of b is less than 1. okay? So if I take the this equation now, and I'm going to make b a slider in Desmos. So this time I'm going to type in y equals, and I'm going to use parentheses now, okay? And I'm going to pick the letter b. So b is going to be my slider. So I'm going to have b, and then times, we'll do the x squared function. Okay, and then remember, click on the letter B. Now it's a slider. So now watch what happens. When B gets bigger, notice it's the opposite of what happened when we looked at vertical for A, right? So as B is getting greater than 1, notice that the graph is getting narrower. So that would be like a horizontal compression or shrink. And then as b is getting smaller than 1, right? So right here, notice it's getting wider. So that would be like a horizontal stretch. Okay, so it's the opposite of what you would see with vertical. So if b is greater than 1, it ended up getting narrower, right? And this is called a horizontal shrink, or you can also refer to it as a compression. And if b is between 0 and 1, the graph got wider, and this was a horizontal stretch. Okay, so let's take a look here. If I take the absolute value function, right, that's my common function, and let's say I put a 3 on the inside. What do you think that 3 is going to do to the graph? So will it stretch it? Will it shrink it? And will it be vertical or horizontal? So the first thing I notice is that the 3 is on the inside. So anytime it's inside, it deals with horizontal, right? Like even if we go back to when we were shifting stuff, right? When it was on the inside, like this right here, that -2 is on the inside of the radical, or this -2 is on the inside of the parentheses. That controls right and left, okay? So here we've got the 3 on the inside, all right? And where does 3 fall? Is 3 greater than 1, or is 3 between 0 and 1? So 3 is greater than 1, so what should happen is it should be a horizontal shrink, and it should get narrower, okay? So let's take a look and see. So all you're going to do is plug in your values for your common function, which you all should already have completed. And I'm going to pick some values here to plug in. It doesn't matter what you plug in, but I'm going to take my x values, right? Horizontal is x, and I'm going to multiply all of my x values by 1/3. Okay, so you're going to take this value here, b is 3, and you're going to multiply by the reciprocal. Okay, so 1/3. So you're going to multiply all these values by 1/3, or divide by 3. So -6 divided by 3 is -2. My y value is going to stay the same. -3 divided by 3 is -1. The y value stays the same. 3 divided by 3 is 1. The y value stays the same. And so far, and same as the last one, 6 divided by 3 is 2. The y value stays the same. Because remember, when you're horizontally compressing or stretching, it's affecting horizontal. It's not affecting the y's. So the y's are staying there. It's the x's that are moving. And that's causing it to get fatter or to get narrower. So if I graph my first function, the absolute value function, we know that that just looks like a V, right? So I'll graph a couple points there just so you can see. Here's one side. Here's the other. Okay, there's your absolute value function. And I'll graph g of x in another color. So -2, 6. -1, 3. 0, 0. 1, 3. 2, 6. As you can see, the y's stayed where they were at. It was the x's that moved. And what do you notice happened? It got narrower. So this was a horizontal shrink or compression. Okay, and that pretty much ends the video. Just kidding, no it doesn't. Okay, so you guys can try this. Let's look at the bottom problem and we'll do this together. Okay, so you've got this function f in blue, and we have here what's called a sequence of transformations. So there could be more than one transformation going on, all right? So I'm gonna write down my 1, 2, 3, 4 blue points. Okay, so these are your blue points. So I see a point at 0, 0, 2, 2, 4, 0, and it looks like 7, comma 4. Okay, first of all, what's this negative doing? So the negative is going to, it's on the outside, right? So it should reflect it over the y. That's what the negative's going to do. Sorry, over x. And then the 2, since that's on the outside, it's affecting vertical. Remember, inside is horizontal, outside's vertical. It's bigger than 1, so this is going to be a vertical stretch. So it's going to take the graph, and you're going to see it's going to reflect it over the x-axis, and it's going to stretch it. So it's going to be twice as big, right? So if I was to look at a new table, all I'm going to do is I'm going to take my y values, because y is vertical. The x's stay the same. I'm just going to multiply all my y values by a -2. So 0 times -2 is 0. 2 times -2 is -4. 0 times anything, 0. 4 times -2, -8. So now if you graph those points, 0, 0 is at the origin. 2, -4 is right here. 4, 0 is there. And then 7, -8. 1, 2, 3, 4, 5, 6, 7, 8 is here. So your graph is going to look something like that. And you can see it flipped over, and also it was stretched vertically by a factor of 2. So it doubled in size. Okay, the last one I'll leave for you to graph, but I will help you with breaking it apart, okay? And if you need help, in the box right there, I gave you steps for sequences of transformation. So if you just follow the steps, it'll help you, basically like order of operations, okay? So let's look first at the function. This is h of x, right? So it's saying you're going to take the f function, you're going to multiply it by a half, and then they have this x plus 1 in parentheses, so that's doing something to the blue graph, and then adding 4. So the 1/2 is on the outside. So anything on the outside is vertical, right? You're multiplying by a half, so 1/2 is between 0 and 1, so that's going to be a vertical compression or shrink by a factor of 1/2. Now I've got this plus 1 on the inside. So anything on the inside is horizontal. And that value there, remember, another way to write it would be x minus -1. So since that's less than 1, that's going to be a horizontal shift left 1. So you're going to see the graph shift to the left 1. Another way to tell is it's the opposite of what you see, right? So I see a plus 1 in parentheses, so that means I'm going to go to the left 1. You would think it would be to the right, but it's not. Horizontal is always opposite. And then the 4 at the end, anything on the outside, remember, is vertical. That plus 4, remember, is what we did in the beginning of the lesson. So that's a vertical shift. Since it's positive 4, it's going up 4. So when you do your graph, you're going to take all of your x values and you're going to double them all. Okay, so remember, you're going to take them and multiply them all by the reciprocal, okay, by 2. Then you're going to take the x values and subtract 1. you're doing the opposite, and then all the y values, you're going to add 4. Okay, that is the end of the lesson. If you have any questions, please let me know. Please get on Desmos and practice these graphs. That'll help you out a lot. Okay, and enjoy the rest of your day.